Hi everyone, welcome to my YouTube channel. Today we will be solving the question of reordering a linked list. So here we are given this question of reorder list, and here we have a singly linked list, and it is represented as L0 till Ln, where L0 is the first node and Ln is the nth node. And we have to reorder this list in this form, where the nth node is between the 0th and first node, n minus 1th node is between first and second, and we can only change the pointers and we cannot overwrite the node values. Like for example, in this example, we are given the linked list 1, 2, 3, 4, so we cannot simply overwrite the second node as 4 and third node as 2 and fourth node as 3. Instead, we have to update the pointers. So basically, we have to move the node 4 here between node 1 and 2. And for the second example, we have to move the node 5 between 1 and 2 and node 4 here between node 2 and 3. So let's have a look at the approach we will use to solve this problem, and let's try to draw some diagrams to understand this. So here we have our linked list, and the first element is L0 and it goes all the way till Ln, and we have to reorder it in a way where nth node is between 0 and 1, n minus 1 would be between L1 and L2, and so on. So for even length linked list, it would go on till kth node, and the last one would be n minus k. So basically, they would be pairs of nodes, and the last pair would be lk and ln minus k. And if the linked list length is odd, then the last node is going to be lk. For the even length linked list, we are given this example where the head is pointing to node 1, and we have this linked list of length 6, and we have to reorder this linked list into this. So the node 6 comes in between the node 1 and node 2. The node 5 is going to be in between node 2 and node 3, and at the end node 4 will remain as it is. For linked list of odd length, we are given this linked list with length 5, and the output is going to be this linked list. So let's try to understand what's going on here. So let's take a look at the linked list with even length. So here, as you can see, we have the node 1 here, node 2 here, and node 3 here, and node 6 is here, and 5 and 4 is here. So as you can see, the first half of the linked list is till node 3, and the second half of the linked list is from node 4 to node 6. And in the merged linked list, the second half is in reversed order. So as you can see, the node 6 and then 5 and then 4, and the first half is in the original order. And from this pattern, what we can see is the first half of the linked list and the second half of the linked list, they are both merged together. So the first half is node 1, 2, and node 3, and the second half is node 4, 5, and 6, and this second half is in reverse order. So if we reverse this, it would be 6, 5, and 4. And if we now merge the first half and second half together, what we are going to get? We are going to get is the linked list with node 1, and then we merge this node 6 between node 1 and 2. We are going to get node 6 here and then 2, and then node 5 is going to be in between node 2 and 3. So node 5 and then node 3, and node 4 will be the remaining node, so it would be just after node 3. So here we have realized this pattern where the second half is in reverse order, and then we are merging the second half into the first half. So before splitting the linked list into two halves, what we are going to need is we have to find the middle node of the linked list. So step 1 is to find the middle node, and then step 2 is to reverse second half, and the final step is to merge second half into first half. So for step 1, what we can do is we have to find the middle of the linked list. So we discussed in finding the middle of the linked list that we can find the middle of the linked list using slow and fast pointers. So for node of length 6, which is even length, the middle of the linked list is going to be node 4. So this is going to be the middle node. And for linked list of length odd, so let me draw the linked list of length 5, 3, 4, and 5. So for this example, the middle of the linked list is going to be node 3. And what we have to do is we have to update the node just before the middle node. So this would be previous, and we have to break the linked list here. So if I break my linked list here and just point it to null, so now I have separated the linked list into two halves. So this is going to be my first half, and this is going to be my second half. And similarly for linked list of length odd, we are going to break here because this is going to be the previous. This is going to be my previous node, and once I update it to null, this way I will separate my linked list into two halves again. So the first half would be of length 2 and second half would be of length 3. So here in this example, for even length linked list, both halves would be of equal length. So both of them are of length 3. And for odd linked list, so the first half is of length 2 and second half is of length 3. So for odd length linked list, the second half is going to be bigger. And now we have to merge these two halves together. So let's have a look at how we are going to merge that. So we have our first half 1, 2, and 3, and we have our second half 6, 5, and 4. So we get 6, 5, and 4 by reversing the second half 4, 5, and 6. So also after finding the middle node, we have to reverse the second half. So the second operation is reverse, and after reversing we have to do a merge, and here we will do a merge. So here we are going to need a reference to node 6, and we are going to have a reference to node 1. So if I call my node reference to 1 as, let's say, if I call this current and this as next, and what can I call the reference to node 6? So what I can do is I can simply just call it temp, and I have to merge this temp node in between current and next. So I have to do an update as this. So current dot next is going to point to node 6, and 6 dot next is going to point to next. And before updating this pointer, we are going to need to save the reference to node 5 so that we don't lose it. So let me call this temp next, and after merging node 6 what we are going to have is something like this: 1, 6, and 2, and then 3, and then we are left with 5 and 4. So here now I have to merge my node 5 between node 2 and node 3. So node 2 is going to become my current, and node 3 is going to become my next, and node 5 will be my temp, and node 4 is going to be temp next. And now I can do a similar thing where I am updating current dot next to point to node 5, and temp dot next will point to node 3. And next, what we are going to have is something like this: 1, 6, 2, 5, and 3, and we are left with node 4, and my node 3 is going to be current, and the next is going to be null, and this is going to be my temp, and I can simply update my node 3 dot next to point to node 4, and temp dot next point to null, and we will be done. So this is a simple example when the length of linked list is even. Now what if the length of my linked list is odd? So for that case, let me draw a linked list with length 5, 3, 4, and 5. So here, after I find my middle node, so here is my middle, I update node 2 dot next to null, and then I have to do a reverse operation. What I'm going to have is node 5, 4, and 3, and my first half is going to be node 1 and node 2. So here, following the same step as before, the node 5 is going to be merged between node 1 and 2. So here we are going to have node 1, node 5, and node 2, and next we are going to have 4 and 3. So here my node 2 will become current, and node 4 is going to become temp. So here we can add simple check where we can check if current dot next is null, then we can simply update current dot next to point to temp, and we will be done. So this is because the length of second half is bigger here. So if we don't add this check, then we're going to lose updating the node 3 into our merge. So that is why we're going to need a check where we are checking if current dot next, or simply next if we are setting that to current dot next. So if current dot next is null, then we can set our current dot next to temp, and since since this is going to be in a loop, so we can break out of the loop. So the loop would be something like where we'll be checking if while current is not equal to null, something like that. And this is just a check when the length is odd, and we are left with last few nodes, and yeah, we'll be done. And this will make sense when we will have a look at the code implementation. So let's dive into the code implementation to understand this better. Now let's have a look at the code implementation for this problem. So here we have to implement the function of reordering list. So here, as we discussed, we need to do three operations. First one is finding the middle of the linked list. Then second one is reverse the second half, and third operation is a merge. So here, for finding the middle node, we are going to use slow and fast pointers, and then we have to update the first half reference, reference of last node of our first half. For that, we are going to need a previous pointer, and for previous pointers, we are going to need a dummy node. So here, let's try to make a dummy node first. So list node dummy equal to new list node -1. Here dummy dot next is going to be head. Then I can create previous node equal to dummy, then my slow pointer and set it as head, and my fast pointer and set it also to head. So here what I'm going to do is I'm going to have a while loop while fast is not equal to null and fast dot next is not equal to null, like following the same logic that we saw in finding the middle of a linked list problem that we discussed earlier. So slow equal to slow dot next, and fast is going to be updated 2 steps ahead. And at the end, what we are going to have, the slow pointer will be the middle node, and the previous would be the node just before slow. So I'm going to update previous dot next as null, and this is going to split my linked list into two halves. And the next operation is reversing the second half. So to reverse the second half, I'm going to create another function to reverse the linked list. So here what I can do is I can create public list node reverse, list node list node current equal to node, list node previous equal to null. So to see the reverse logic, please have a look at my reversing the linked list video. So here while current is not equal to null, and I'm going to have to save the reference to next, current dot next. So here current dot next would be previous, and then my previous would be equal to current, and current would be equal to next. And at the end, I have to return previous, because previous would point to the head of the reversed list. So here what I can do is I can simply update my slow pointer and pass it to my reverse function. So here initially slow points to the head of the first half, and now slow, after calling the reverse function, it's going to point to the head of the reversed second half. So next step is the merge step. So for our merge step, what we are going to do is we're going to create another variable and call it current, and we're going to have to save the reference to the first node of our first half, and that is going to be dummy.next. And we are going to have a while loop while current is not equal to null. And now what I have to do is I have to store the next references to my first half and my second half. So the next reference of my first half would be current.next, and next reference to my second half is going to be slow.next. And what I can do is I can update my current.next equal to slow, and slow.next equal to temp1, and then I have to update my current and slow. So current would be equal to temp1, and my slow is going to be equal to temp2. And this works well for linked list of even length. So for linked list of odd lengths, I have to add another check. So here I can simply add if temp1 is equal to null, and then I can update my current dot next equal to slow and break out of the loop. Okay, so let's try to run this and see if we made any errors. Okay, that works, which is good.